A wheel turns at 0.35 revolutions per second. The relationship between the number of revolutions r and the number of minutes that have passed m, so they're doing it in the number of minutes, not the number of seconds that have passed, is shown in the graph below. Which of the following describes the relationship between the units shown in the graph? So the first thing I want to do is just see, does this graph make sense? Is it consistent with the wheel turning at 0.35 revolutions per second? And to see that, since their time axis right over here is in minutes, I want to re-express 0.35 revolutions per second in terms of revolutions per minute. So 0.35 revolutions per second. I want to write this as revolutions per minute. So what I really want to do is multiply it times something that is in the units seconds per minute, because then the seconds will cancel out and I'll have revolutions per minute. Well, we know that there are 60 seconds for every 1 minute, and so this is essentially the same quantity in the numerator and the denominator. 60 seconds is equivalent to 1 minute, and so this is essentially equivalent to multiplying by 1. We're not changing this measurement right over here, or we could even write this as 60 seconds per minute. And when we do that, our seconds cancel out, and we are left with 60 times 0.35 times 0.35 revolutions per minute. Revolutions per minute. Now, what's 60 times 0.35? Let's see. 60 times 0.3 is 18. And then we're going to have another 3, because 60 times 0.05 is 3. So it's going to be 21. So this is going to be equal to 21 revolutions per minute. Now, is that consistent with what we're seeing in this graph? Let's see. After 2 minutes, we should have 42 revolutions, and that looks pretty close to 42 revolutions. After 5 minutes, we should have 105 revolutions. Yep, that looks like what this graph is definitely doing. So it is definitely consistent with this information. Now let's see which of these statements are reasonable. The units of the slope would be the same if the x-axis were in revolutions and the y-axis were in minutes. So let's remind ourselves what slope is. Slope is defined. It's not just a rate. The slope is the rate of change of the vertical axis, of the y-axis, with respect to the horizontal axis. So the way that the graph is set up right over here, this would be the rate of change of our revolutions with respect to the rate in change of our minutes, or m. I don't like using m because m could be confused with meters, but they did that here. So what is that? Our slope is, well, it's when 1 minute has passed. So let's think of it this way: when 1 minute has passed. So our change in minutes is 1, we have 21 more revolutions. So our slope right over here is 21. Our slope right over here is equal to 21. If you change the axes, if you made the vertical axes be time, and if you made the horizontal axis be revolutions, then your slope would be the reciprocal of this. It would be change in time over change in revolutions. It would be 1 over 21. So it's definitely not going to be the same slope. So that is definitely not true. A graph containing this information could use revolutions and hours. Well, sure, we would have to change the scale. So let's think about it a little bit. We could definitely construct a graph that had it in terms of hours. So for example, right now there's 21 revolutions per minute. But if we multiplied that by 60, we would essentially have revolutions per hour. Let me write this down. 21 revs per minute times 60 minutes per hour give us 6 times 21 is 126. So it's 1,260 revolutions per hour. So you could definitely construct a graph that has that information. So if you had, so this is the hours, 1 hour, 2 hours, 3 hours. So that's our hours right over here. And this is revolutions, but here you'd probably want to do it in thousands. So 1,000, 2,000, 0 hours, you'd have 0 revolutions. 1 hour, you have 1,260, would be right around there. And so you would have a line that looks something like that. But the obvious thing is, yes, you can definitely do that. You could definitely contain this information using revolutions in hours. Now let's look at the last statement. The rate at which the wheel turns is the number of revolutions divided by the number of minutes. Sure, the rate is, which is actually in this case because revolutions is on the vertical axis and minutes is on the horizontal, the rate is the slope. So the rate at which the revolutions change with respect to time on this graph, the way it's depicted, is revolutions per minute. What is my change in revolution? So as I go from, say, this point to this point, how much have my revolutions changed, my change in R, for a given change, for my given change in minutes? So change in revolutions divided by change in minutes. So this is definitely true as well.